it stopped. So it stopped the recording, so make sure you watch the first part of the video before you watch this part. Some of your problems will say factor the expression, and then it'll give you a linear expression like, let's do 24a plus 36. When you have an expression like this, you have to factor both of these terms first. So we'll make a factor tree. I know 2 times 12 is 24, 2 is prime, so I'll stop there, but I have to keep going with the 12. 12 is 3 times 4. The 3 is prime, but the 4 is composite, so I keep going. 4 is 2 times 2. Those are both prime, so I'm done. Then I'll do the 36. 36 I know is 9 times 4. Those are both composite. 9 is 3 times 3. Those are both prime. 4 is 2 times 2. Those are both prime. Then I'll do just like I did before. I'm going to write them on top of each other like this. 24a is, and I always go smallest to biggest, 2 times 2 times 2 times 3. 2 times 2 times 2 times 3 times a. And 36 is 2 times 2 times 3 times 3. Going smallest to biggest just makes it easier to find matches, so these match, and these match. They don't have to be right above each other. We take one from each match and multiply them together. So 2 times 2 times 3. 2 times 2 is 4, times 3 is 12. That means my greatest common factor is 12. But we're not done. We have to factor this whole expression. So I'm going to write a 12 on the outside of my expression. Whoops, I don't need parentheses yet. 12 is on the outside of the parentheses. And so basically I'm dividing this whole thing by 12. This is the opposite of the distributive property. So 24a divided by 12 is 2a. If you're ever unsure what's left over that goes back in here, it's what's here. 2a that's not circled, that goes here. Then I have a plus here, so I'm going to put a plus here. And then 36 divided by 12 is 3, which is also my only thing that's not circled here. Again, this is the opposite of the distributive property. If I were to distribute this 12 and use the Santa hat here, I would get this expression over here. So this whole thing is my answer. Alright, let's do one more. So this last one is going to say factor the expression. Let's do negative 18xy minus, let's do minus 27x. I don't know why that x turned out so bad. Okay, I started the same way. I've got to make a factor tree for both of these terms. 18 is 9 times 2. 9 is 3 times 3. I've got all primes, so I can stop. 27 is 9 times 3. 9 is 3 times 3. And those are all primes, so I can stop. I have to write them on top of each other, so I'm going to write negative 18xy equals, I need to remember my negative sign. That's not going to show up in my factor tree either. 2 times 3 times 3 times x times y. The negative and the variables are not going to show up in your factor tree. I should have done what here at the beginning? I should have changed the sign in the one behind. So for 27x, I need to put, negative 27x, I need to put my negative sign. Negative 3 times 3 times 3 times x. Then I'll look for matches. The negatives match, the 3's match, and the x's match, and another set of 3's match. So I have negative 3 times 3 times x. Negative 3 times 3 is negative 9, times x is negative 9x. So my greatest common factor is negative 9x. I'm not finished. I put this on the outside of my parentheses. And I divide this by negative 9x. Remember, if you don't know what should go in here, it's what's left over here. Negative 18xy divided by negative 9x is positive 2y. That's what's left over here. plus, I have a plus right here, negative 27x divided by negative 9x is 3. That's the only thing left over here. So this is my final answer. Again, if you wanted to check your work, you could distribute the negative 9x, and you should get the same thing as you started with over here.